Hey, what is up everyone? Welcome back to the channel. I am Code Hero, a staff software engineer with over 18 years in the industry. And today, we are going to talk about one of the most fundamental building blocks in Swift, the struct. If you are just starting your journey in iOS development, this video is for you. We'll understand structs through 6 key ideas, starting with a basic struct to see how Swift groups data, then a custom initializer to control how values are created. Next, a computed property to derive values, and a mutating method to safely modify state. We'll then cover value type behavior to understand how copying works, and finish with protocol conformance to show how structs scale in real-world code. And I will walk you through 6 concrete examples so this concept clicks for good. Let us get into it. A struct, short for structure, is a value type in Swift that lets you group related data and behavior together under a single named type. Think of it like a blueprint. You define the shape of your data once, and then you can create as many copies of it as you need. When you use a struct, you define a type with stored properties, and Swift handles most of the boilerplate for you. Structs are built around value semantics and immutability. You create a complete value upfront and avoid mutating it unless it's explicitly needed. var property, mutating function. This leads to more predictable state and fewer side effects. Swift also provides a member-wise initializer for free, so you don't need to write an init unless you want custom behavior. You can instantiate the struct by passing its properties by name directly. Semantically, this reinforces that a struct is data fully defined at creation time, not something that changes implicitly over time. Now here's the key difference that separates structs from classes, and the one that matters most. A struct is a value type. It gets copied. A class is a reference type. It's shared. This isn't just theory. This directly affects how your data behaves in memory, how state changes propagate, and how bugs appear in your app. As an iOS developer, understanding this is critical. Structs give you isolation and predictability. Classes give you shared state and identity. Remember, structs are value types. That means when you assign a struct to another variable, or when you pass it into a function, Swift makes a full independent copy of it. Let's walk through a simple struct example. When we assign point A to point B, Swift creates a copy, not a connection. This is what value semantics means. When you assign or pass a value, you get an independent copy, not shared state. From that moment on, both values live separately. So when we do point B property x equals to 50, we're not creating another copy. We're simply modifying the existing point B value. Why? Because the copy already happened during assignment. Point B already owns its own data, so Swift can safely mutate it in place. That's the key idea. Copy happens on assignment. Mutation changes the existing value. The compiler often optimizes the change to happen in place in memory, rather than literally copying and deleting the old one. No shared state, no side effects, just predictable behavior. That's the power of value semantics. Classes, on the other hand, are reference types. They live on the heap, and multiple variables can point to the same instance. Structs live on the stack, which is faster to allocate and deallocate, and there is no risk of unintended sharing. This is why Apple and the Swift team recommend preferring structs over classes in most cases. Let us talk about memory for a moment, because this is something beginners often skip and then regret later. When you create a struct instance, Swift typically allocates it on the stack. It is extremely fast because the CPU manages it directly through a pointer. When a function returns, the frame is popped off the stack and all that memory is reclaimed instantly. No garbage collection, no reference counting overhead. This is one of the reasons SwiftUI is built almost entirely on structs. Every single view in SwiftUI is a struct. Use a struct when you are modeling simple data like coordinates, colors, sizes, or configurations. Use it when you want value semantics, no inheritance, or when you want thread safety by design. Use a class when you need identity, meaning 2 variables should refer to the same object, or when you need inheritance. Alright, now let us look at 6 real-world examples so you can see structs in action. Example 1. Let's start with a basic struct. Here we define a type called person. It has 2 properties, name and age. This is the simplest form of a struct, just a way to group related data. Now notice something important. We create an instance of person by passing a name and an age. We didn't write an initializer, and yet it works. That's because Swift automatically provides a default initializer for structs. It takes each property and lets you pass values directly. So here, we create a person with the name Alice and age 30. Then we access the data by reading the name property, and the result is Alice. Simple, predictable, and with almost no boilerplate. That's the power of structs in Swift. Example 2. Now let's look at a struct with a custom initializer. We define a rectangle with two properties, width and height. But instead of using the default initializer, we create our own. This initializer takes a single value called side. Inside it, we assign that value to both width and height. So instead of passing two separate values, we can create a square using just one. When we initialize rectangle with side equal to 5, both width and height become 5. This gives us more control over how our data is created. Instead of allowing any combination of width and height, we can enforce specific rules, like always creating a square. That's the purpose of a custom initializer, to control how your struct is created and ensure your data is always valid. Example 3. Now let's look at computed properties. We define a circle with a radius, but instead of storing the area as a value, we compute it dynamically. The area is calculated using the formula pi times radius squared. This is what we call a computed property. It doesn't store data in memory. It calculates it every time you access it. So when we create a circle with a radius of 3 and then access the area, Swift computes the result on the fly. This keeps our data consistent. We don't need to worry about updating the area manually if the radius changes. That's the key idea. Stored properties hold data. Computed properties derive data cleaner, safer, and always up to date. Example 4. Now let's talk about mutating methods. We define a counter struct with a single property, count, starting at 0. Then we add a method called increment. But notice the keyword mutating. In structs, methods cannot change properties unless they are explicitly marked as mutating. This is because structs are value types, and Swift protects their state by default. So when we call increment, it increases the count by 1. But there's one important rule. The instance must be declared as a variable. If it were a constant, we wouldn't be allowed to change it. So we create a variable counter, call increment, and the value updates from 0 to 1. That's the key idea. Mutating allows a struct to change its own data, and Swift makes you be explicit about it. Example 5. Now let's look at value types. We define a point with two properties, x and y. Then we create point A with values 1 and 2. Next, we assign point A to point B. This is where something important happens. Swift creates a copy, not a reference. So now we have two completely independent values. Then we change point B, we set x to 99. And notice the result. Point A stays the same, 1. Point B changes to 99. This is value semantics in action. Each variable owns its own data. There's no shared state, no hidden connection. Changes are isolated and predictable. That's why value types are so powerful in Swift. Example 6. Finally, let's look at protocol conformance. We define a protocol called describable. It requires a function called describe that returns a string. Then we create a struct called car and make it conform to that protocol. This means car must implement the describe function. Inside it, we return a string that combines the year and the make. Now when we create a car instance, we can call describe and get a formatted description. This is powerful because protocols define behavior, not data. And any struct that conforms to the protocol can be used in the same way. That's the key idea. Protocols define what something can do. Structs provide the implementation. Alright, let us wrap this up. A struct in Swift is a value type that lives on the stack, making it fast and memory safe. The Swift team and Apple have been clear about this. Prefer structs. Only reach for a class when you need reference semantics. Before you go, drop a like, subscribe, and leave a comment below. It really helps the channel grow. Share this with a colleague who needs it. I'm Code Hero. See you in the next one.